In the last lecture we had seen how a wave propagates, how the sound wave is generated when a body moves, and we have also seen how the pressure changes due to density changes related to the velocity of sound. Okay. So, in this lecture we are going to see the consequence of a particle or object moving in gas and the effect of relative velocity between the sound wave and the particle velocity or the object bluff body velocity. Okay. So, we are going to see the wave propagation when an object moves in space. So, if an object moves in space, it is going to create a pressure change, which is going to create a wavefront that is moving ahead of the body, and that velocity of the wavefront is what we have derived to be the velocity of the sound. Now, the problem what we have is, whenever there is a motion of the body, there will be a sound wave that is moving ahead of it. Now, there is a relative velocity between the body and the velocity of the sound. Now, what are the consequences of these relative velocity is what we are going to see. So, what I am going to do is, what I will assume now is, I have a point source and I will assume that this point source is going to generate some wave. So, I have a point source and this is going to generate sound waves, and these sound waves are going to be spherical in nature. Okay. So, what I will do now is, say after 3 seconds or 4 seconds, I will just look at where the waves are. Now, you have infinite number of waves that is generated from the point source. So, we will concentrate only 3 waves which is generated at the 0th second, 1st second, 2nd second and the 3rd second. Okay. So, and we will take a snapshot of the view. So, what I will do is, first let me define something. Velocity of sound is a meters per second. Velocity of the object or the bluff body or whatever is v. Okay. Our aim is find a snapshot at the 3rd second after your okay. So, after t equals 3 seconds. Okay. So, I am taking a photograph okay, after 3 seconds from the t equals 0 condition. So, I have a point object. The first case I will assume v equals 0, which means the point source is stationary, and I will assume this is uniformly the sound wave is uniformly generated. So, I have here a thread. So, there are 3-4 nodes. The distance between each of these nodes is say a. Okay. So, at 1 second the light wave would have travelled a distance. At 2 seconds the light wave would have travelled 2 seconds, and at 3/3 second light wave would have travelled 3a. Okay. So, now the snapshot at t equals 3 seconds. So, the wave that is generated at the 0th second would have travelled 3a distance. So, I take a length of 3a okay, and I am going to draw a circle. Okay. So, this is wave emitted at t equals 0, and now we are watching at the third second. Okay. So, from t equals 0 to t equals 3, the wave travelled 3a distance. So, this distance is 3a, fine. Now, the wave that is generated at t equals 1 would have travelled 2a distance. So, I take distance 2a and draw a circle. Okay. So, this is my wave emitted at t equals 1 after seen after 3 seconds. Now, wave at t equals 2. So, wave at t equals 2 would have travelled only a distance because the difference is only 1 second. So, in 1 second the wave travelled just a distance. So, the wave that is generated at t equals 2 would have travelled just a. So, this is just a, this is just 2a, this is just 3a. So, I repeat. So, at the third second the wave have just generated, but it has not travelled anywhere. So, this would be the wave that is going to be at the source itself. Okay. So, I repeat. So, this is the wave that has travelled 2a distance from t equals 0 viewed from with a velocity a. So, this distance is 3a. So, you are viewing it at a snapshot of 3 seconds. So, at 3 seconds this is what you would see if I have consider only these 3 waves. There are, remember, there are infinite number of waves in between, but we are concentrating on just these 3 waves, right. Here the wave, the source is stationary. So, source is not moving at all. Okay. So, the wave that is generated at the third second still stays there. The wave that is generated 1 second earlier is seen at a distance a. The wave that is generated at 2 seconds earlier would be seen at distance 2a. The wave that is generated 3 seconds earlier is seen at 3a. So, these are spherical, if it is a 3D, if it is a source and its space is 3D, these are all spheres, that is concentric spheres at this with the center as the source. Now, consider V is a by 2, which means the source is moving at a velocity half the velocity of sound. So, I would again snapshot at t equals 3 seconds. So, at t equals 0, the source is here. I will mark it with a red color. Okay. So, at t equals 0, seen after 3 seconds, the wave would have travelled 3a distance. So, I take 3a in my scale and draw a circle. So, this is the wave that has generated at t equals 0 seen after 3 seconds. So, this is emitted, wave emitted at t equals 0. Okay. Now, at t equals 1, the source would have moved a distance a by 2. So, I take a by 2 and I mark that point. So, at a by 2, at a by 2, the source has moved at t equals 1 the source has moved a by 2 distance. Now, the light the wave emitted at at t equals 1 would have travelled 2a distance if you are taking the snapshot at 3 seconds. Okay. So, I take 2a and I draw a circle. Okay. So, this is the wave emitted at t equals 1. Now, at t equals 2, the source would have moved a distance another a by 2. So, this is t equals 2. So, at t equals 2, there is a wave that is emitted that would have travelled a distance if you view it from at the third second. So, I take a distance and I draw a circle. Okay. So, at the third second, the source would have moved another a by 2 distance, but the wave would not have moved anywhere because we are taking the snapshot at the third second. Okay. So, the wave is still there at the source. So, again I repeat, so the source is moving at velocity a by 2. So, at every second the source moves a by 2 distance, but the wave that is generated at the initial point, which is at t equals 0, would have travelled 3a distance if our snapshot is at third second. So, the wave that is emitted after 1 second at t equals 1 would have travelled 2a distance. So, this is 2a, the radius of this circle is 2a, the radius of this circle is 3a, radius of this circle is a. So, just that the circle is moving at a different speed. Okay. Fine, we will come back to the consequence later, but this is the picture. So, you have a wave that is moving, the source is moving behind the wave is always ahead of the source. So, the point here would somehow know that the source is coming before the source reaches that point, okay, because the wave is going to reach before the source. Okay. This is the case of so called subsonic flow, where m is less than 1. So, here a velocity of sound, velocity of the source is less than the velocity of sound. So, what we have drawn here is for the case of m equals 0.5. So, in Mach number 0.5, the source is moving half the velocity of the sound, and any point in the space will know about the approaching source much before the source reach the point. Now, let us look at the next V equals A, again snapshot at t equals 3 seconds. Okay. So, I have a source located at some point here. So, my 3A would be this. At t equals 0, this is the wave emitted at t equals 0, taken the snapshot after 3 seconds. So, this distance is 3a. So, the source, the wave that is emitted at the source at t equals 0 would have travelled a distance 3a if you look at it after 3 seconds. Now, after 1 second, the source would have moved a distance of a. Okay. source would have moved a distance of a. So, this is at t equals 1, this distance is a, which is the velocity of the source. So, the source would have moved a distance a, and you are viewing it after 3 seconds. So, that it would have travelled a distance of 2a. So, I take 2a distance and draw the circle. Okay. So, this is 2a, this is the wave emitted at t equals 1. Now, at t equals 1. Now, at t equals 2, the source would have moved a distance of a, another distance a. So, this is t equals 2, and you are trying to see where the wave is after 3 seconds. So, that the wave that is generated at t equals 2 viewed at the snapshot of 3 seconds would have travelled a distance of a. So, in 1 second the wave would have travelled a distance of a. Okay. That is the location of the source at t equals 2. So, this would have travelled a distance a. Okay. So, the source at t equals 0 travelled a distance 3a, source at t equals 1 travelled a distance 2a, source at t equals 2 travelled a distance a, and source at 3 seconds would have travelled 0 distance. It is just located at the source itself at after 3 seconds. Okay. So, the source moves along with the velocity of sound, moves along with the sound wave. Okay. So, a point here will know about the source only when the source hit the point, because the waves are also moving along with the, there is no information ahead of the source, okay, unlike in a wave subsonic flow, where the point here, somebody standing here will know about the approaching source much ahead of the source itself, whereas here the person standing here will know about the source only when the source reaches the point. So, this is the case of m equals 1, where your V is equal to your A. Now, for the supersonic case, if my V is 2A, so again snapshot at t equals 3 seconds. So, at t equals 3, t equals 0, the source is somewhere here, and after 3 seconds it would have travelled a distance 3a. So, it would have travelled a distance 3a. This is wave emitted at t equals 0. Okay. Now, at t equals 1, the source would have travelled a distance 2a. So, 2a is here. Okay. And at 2a, if I am viewing it at t equals 3, the wave would have travelled for 2 seconds. So, the distance it has travelled is 2a. So, I take 2A and I draw the circle. Okay, so, this point would be exactly on this. So, this is 2A. So, 2A is the distance that the wave travelled in 2 seconds. The wave that is emitted at t equals 1, this is t equals 0. So, this is wave emitted at t equals 1. Now, after another second, the source would have moved a distance 2A. So, the 2A is here. And in this is at t equals 2. So, the wave would have travelled a distance of A in 1 second, which is what I would draw here. Okay. So, this is the wave source at t equals 2, this is the wave emitted at t equals 2. Now, at t equals 3, the source would have moved a distance 2A. So, the source is here at t equals 3, and the wave generated at t equals 3 would be there itself at the location of the source. So, the source is much ahead of your wave. Okay. So, by the time for somebody standing here, there is no information about the approaching source, and he will know about the source from the wave only after it has passed the location. Okay. So, this is for the case m equals 2, where your V is 2A. Now, so that is the consequence of what we are been discussing. So, in subsonic flow, you always have the information of the approaching source in the form of waves much ahead of the source itself, whereas in sonic case you have the information only at the point when the source approaches the point along with the wave, whereas in supersonic you will know about the wave only after the object has passed the measurement point or the observation point. Okay. Now, further to this, you can have, so if I draw these things and if I draw the tangent of this, I would get, I will take another color. With the source at the vertex, I can draw a tangent along this, and similarly I can draw a tangent along this that touches the source. Okay. So, at the third second, this is where the sound waves are located. After this, or the region outside this line, there is no wave. So, this region outside the so called outside this line, which would be 3D in nature, which is called a Mach cone. Okay. So, outside this region is the so called zone of silence, because you will not know about this till the wave reaches somewhere here. So, if somebody here will know about this wave only when this cone would have reached this point, which means the source would have moved further away and the cone would have enlarged itself. Okay. So, this region is the zone of silence, and these waves are called Mach waves. Okay. So, the Mach wave will approach this observation point only when this observation point is inside the cone. Okay. So, if I have a projectile moving ahead, this will generate a Mach cone, and you will know about the waves only if you are inside the Mach cone. Outside it is the zone of silence, you will not know about the waves generated or the noise that is generated. Okay. Now, this has consequence. So, if I have so if I have an aircraft that is moving, and there is an observation point here. So, let us say if v is a by 2, or the velocity is the Mach number is subsonic. Okay. If the Mach number is subsonic, from this diagram we know that even before the vehicle reaches this observation point, there is some wave that would reach here. So, even when the vehicle is somewhere here, you would know about the location of the vehicle, or you will hear the vehicle, hear the aircraft. Whereas, if it is running at supersonic condition, the observation point will see and hear at the same time. Okay. If it is at m equals 1, you will hear and see the vehicle at the same point of time. Whereas, in supersonic case, you will hear it only after some time. The vehicle would have passed you before you could hear the noise. So, the time difference between seeing and hearing can be used to find the velocity of the vehicle itself, velocity of the aircraft. Okay. So, we will do some examples later on. So, that is how the relation between your velocity of sound and the velocity of the object, or the velocity of the gas, or whatever. Fine. So, what we have learned today is the way in which the wave propagates if there is a relative velocity between the source and the velocity of sound, and that has direct consequence in what we are discussing in this course, which is this. Okay. And we will do the problems in a later point of time.